This is a Year 10 Higher Maths lesson on summary statistics, and this is lesson 3, the median and quartiles from unsorted data. So the algebra test scores for 2 Year 10 maths groups are recorded below. Find the median and range and hence compare groups A and B. Explain if it is fair to compare the ranges in this example. So to start off with, I've put both of the groups in order to save a little bit of time. And we know this is what we need to do if we want to find the medians. Now the median is the middle value. So here we've got 13 values. Okay, so the middle one should be the 1, 2, 3, 4, 5, 6, 7. And we know this because it leaves sort of 6 values either side of that. And it's just worth noting that when you're finding the median and you have an odd number of pieces of data, then you'll have an exact value in the middle. Unlike this one here, where you've got an even number, okay, you've got 16, and you should find that the values in the middle, which are these two here, there will be 2 of them. And to find the median, you obviously pick the value in between the 2 middle ones. So the median in this case is going to be 15. Now, to find the range, we simply look at the difference between the highest and lowest scores. So 20 take away 5 gives us a range of 15 here. And 19 take away 10 gives us a range of 9. Now, it says here to explain if it's fair to compare the ranges in this example. Well, the medians, yes, okay, we can see that Group A have done ever so slightly higher, okay, if we compare the medians, 16 versus 15, than Group B. But it would seem that Group B have results that are much less varied than Group A. Okay, their range is 9 compared with 15 here. However, the reality is that the only result that is making Group A so much more varied than Group B is this one here. If we didn't have that result, then the ranges would be much more comparable. Now, we can't just get rid of it. It's what's known as an outlier. It doesn't fit perhaps within the normal pattern of the data. So we can't just get rid of it. That wouldn't be fair. So what we're going to do, okay, today is look at using something called the quartiles. And using these quartiles, they basically, by finding the middle of the top and bottom half of the data, they allow us to ignore these extreme values, these outliers that perhaps don't fairly represent the whole of the data. So, for example, if we were looking at Group A, the middle of the bottom half of the data would be these 2 values here, and if we take that, we would say that the lower quartile would be 12, and these 2 values here represent the middle of the upper part of the data, okay, giving a value of 17.5. And this is what we refer to as the lower quartile and the upper quartile, sometimes called the first quartile and the third quartile. If we were to do the same for the bottom, okay, find the middle of the bottom half of the data and the middle of the top half of the data, lower quartile, upper quartile, we can see the distances between these two, okay, the distances between 17.5 and 12 is only 5.5, and the distance between 17 and 12 is only 5. And what we've done there is calculate something called the interquartile range, okay, which is the distance between the middle of the top half of the data and the middle of the bottom half of the data. And as you can see, if we actually look at that middle bit of the data, ignoring the extreme values at either end, then we can see that the Group A are almost exactly the same sort of variation as Group B. And this is what we want to be able to do today. Okay, we want to be able to find these quartiles and use them to compare two sets of data. Looking at this example, the time taken in minutes for a teacher to drive to school are recorded below. Find the median and range for the time taken by car. Find the upper and lower quartiles and draw a box plot to show these summary statistics. Okay, so again, to save time, I have placed all these pieces of data in order already. So we are going to start off by finding the median and range. Well, the median is going to be the value in the middle. Well, there are 15 pieces of data, okay, which means that the 8th one should be the one that's in the middle. 1, 2, 3, 4, 5, 6, 7, 8. If I just double check, there should be the same number of pieces of data either side. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I have found the middle value there. So we know that the median is equal to 28 minutes. And similarly, the range, 48, take away 22. 48 take away 22 is going to give me a range of 26 minutes. Now, the only problem is that that 48 is a little bit of an outlier. Okay, it's an extreme value, so it represents perhaps a time when the teacher's got maybe stuck in traffic, or there's maybe been an accident. It represents an unusually long time to get into school. So what we can do is, by finding the lower and upper quartiles, we can essentially ignore those outliers, those extremes, and just look at the range of those quartiles and see if perhaps see what the true variation is. Okay, so for B then, the upper and lower quartiles. Well, remember, the lower quartile is the middle of the bottom half of the data. So that tells me there that the lower quartile is going to be 25. And the upper quartile is going to be the middle of the top half of the data, which tells me that 30 is going to be the upper quartile. Therefore, if I look at what we call the interquartile range, okay, the interquartile range, 30 take away 25 gives me a interquartile range of 5 minutes. Okay, and the benefit of doing that, as I say, it ignores the extreme values at either end of the data. Now, what we're going to do next is draw a box plot to show these summary statistics. Now, you can see with this box plot that I've another one that's been drawn here for the times taken to school by bus. You can see that was the lowest time taken, the quickest. We've got the lower quartile here, the median, the upper quartile, and the highest value, the longest time it took to get into school. Well, if we can plot those same summary statistics for the car, we should be able to use those box plots to make a comparison. So the lowest time to get to school by car was 22 minutes, which is there. The highest time to get to school by car was 48 minutes, which was that one there. The median time was 28 minutes, which is that one there. The lower quartile was 25 minutes. And the upper quartile was 30 minutes. Okay, and those the quartiles there are all joined together by horizontal lines like so, and then we put horizontal lines here and here. Okay, so there we go. That is the box plot drawn for the car. But hopefully now we should be able to use those two box plots to compare the times taken by car and bus. And you'll remember from previous lessons that if we do want to make a comparison, we have to have a measure of location compared and a measure of spread. And measure of location represents an average. So if I look at the medians, okay, I can see that on average the car is significantly quicker than the bus. In fact, it's on average it's 8 minutes, okay, quicker. So that would be the first comparison that I could make. So I could say on average the car is 8 minutes quicker than the bus. Okay, so on average the car is 8 minutes quicker than the bus. So that's dealt with the measure of location. The other comparison we need to look at is the measure of spread, and we can either comment on the interquartile range or we can comment on the full range. I'm going to use the interquartile range here because that's obviously what we've introduced this lesson, but you could use the range as well. So if we look at the interquartile range, we can see that the interquartile range for the bus is ever so slightly less than the interquartile range for the car. Therefore, the times taken are less varied when you travel by bus. So we're just going to write that down. So we can say something like, by bus, the time taken to travel to school is less varied. Now just remember, you can, as long as you make the same comparisons, you can give them a different way. So you could say on average the bus is 8 minutes slower than car, and you could say that by car the time taken to travel to school is more varied. It doesn't matter as long as you're making those two comparisons.